Hello, this is our second class on X-rays. What we will learn today is about the spectrum of X-rays. About the spectrum. Now, a lot of students might not know what is a spectrum. Let's say what a spectrum is. Actually, whenever any kind of energy interactions are happening, any sort of energy interactions, just like you are heating an object or cooling an object or any other kind of transmissions are occurring, we can find out simple graphical values of the emitted energy. We can easily plot the intensity, and in the x-axis we can plot the wavelength. This intensity versus wavelength graph is called the spectrum graph of those quantities. Similarly, for X-rays, we can find emission at multiple wavelengths, and hence if we plot those wavelengths in the graph, we will find out the total spectrum. So we will plot the graph of the X-ray. We find that if we plot it properly, this side is lambda, that is wavelength, and this side is intensity, so I'm writing as I. We will find out that the graph quite looks like this. The graph starts at some value like this, then it moves up, then it is coming down. Suddenly, a first choke, just peak here, then again, first peak, second peak, and it goes on. So this is how the graph looks like in case of X-rays. So we can see here there are actually two kinds of radiations we have got. One portion is which is completely like this, going continuously. Here I'm just marking in the blue part. That portions are continuously present, and hence they are called continuous spectrum. This continuous spectrum begins at some wavelength lambda minimum. The starting wavelength at which this continuous spectrum begins is called lambda minimum, and this is independent of the material we are using. It actually depends on the voltage applied. Voltage applied on the X-rays. On this voltage, the value of lambda minimum depends at which minimum wavelength we can observe the emission intensity. And one more important kind of radiations we can see, which are quite like here. Two peaks here, I'm marking with red, another two peaks here. These are not continuous, rather they are separated. These two parts are called discrete spectrum. Discrete spectrum. In terms of importance, the discrete spectrum are more important because they tell about the character of the material from which the X-rays are coming. And hence those discrete lines are called characteristic spectrum lines. Characteristic spectrum lines. So we got two kinds of spectrums. The first kind is continuous. The first kind is continuous, and second kind is called characteristics. Okay, another question appears: from where these characteristic spectrums are coming and from where these continuous spectrums are coming? The first question occurs that any kind of spectrum that occurs any kind of spectrum that occurs, these spectrums are coming why? Due to some energy emission. Due to some energy emission. Clear? And how this energy emissions going happening in cases? Now, what happens for the production of X-rays are that we know that in case of emission of X-rays, the main phenomenon happening, which is that the electrons are striking the target gets energized, and later this target emit the energy as X-rays. Though most of the portion of the it is emitted at heat, which is more than 95%, and X-rays are actually 1% to 5% of its total heat energy it gets. So basically, electron gives some energy to the target, and target emits those energy in forms of X-rays we observe. Now, any kind of target material is formed of a nucleus in the center, and the electrons are rotating in outer orbits like this. Electrons are present in the outer orbits like this. Now, when these electrons bring the energy to the system, what happens? The atom gains those energies, and if that energy is a normal level of energy, in that cases the electrons in the orbits just vibrates, and due to their vibration, the energy they emit, due to their vibration at their position, their energy they emit forms the continuous X-ray, portion. Clear? This is the main reason behind the emission of continuous X-ray spectrum. Clear? They depends on how much energy the atom is absorbing, and due to this absorbing of energy, the electrons vibrates, and due to their vibration, we can find out the continuous X-rays. But sometimes these electrons bring a good amount of energy with them. The electrons brings a good amount of energy with them. As a result, they kicks out an electron. Just like electron, we know they are in the K, L, M, N, and so on in the orbit. They kicks out an electron from the orbit. So now, due to the energy coming from the electrons, one of the electron inside the K orbit is kicked out of its spot. So as a result, what happened? In this position, a blank space is created as the electron was thrown out of its orbit. So what will happen now? Now, electrons present in the higher orbit will jump to fill this space in the K orbit. So you can see from the L orbit to the K orbit, the electrons will jump to fill the space in the ground state orbit. Clear? And this is the reason when this jump is occurring, the corresponding amount of energy will come out. And this energy is the reason behind those characteristic spectrum. So, what we know, that two kinds of spectrums are present. One kind of spectrum is continuous spectrum, another kind of spectrum is characteristic spectrum. The electrons which are thrown from the source hits the atom in the target, and sometimes those energized electrons bring vibrations in the orbits, and that is the reason behind this continuous spectrum. the vibrating electrons. But if somehow the energy is so much that one of the electron is thrown out of its orbit, and then what will happen? The electrons from the higher orbits jumps to fill up their space. In that situation, we find out these characteristics X-ray spectrums. Clear? Now, these characteristics X-ray spectrums actually tells us about the strength of the molecular bindings, and hence the energy we can find out. Using that, we will find more details about the target we are using. We will find that thing in the Moseley's law, but before that, we are also going to tell you that due to this energy emissions, if the electrons in the k orbit jumps, then we find out two characteristic lines which we name them as k alpha line and k beta line. If this thing happens in the L orbit, we name them L alpha line and L beta line. Clear? So this kind of things are happening which are reason behind the characteristics X-ray spectrum. The next portion is that how does this characteristics X-ray spectrums help us to understand more about the target. Moseley found out that these characteristic spectrums are something special. He found out that these characteristic spectrums are quite special. Now, when these characteristic spectrums are coming out, they have a certain frequency of nu. He found out that the square root of that frequency is proportional to the atomic number. The square root of the frequency is proportional to the atomic number. Okay, and for this equation, this relation is known as Moseley's law. Most of the numericals in the chapter are depending on the Moseley's law. This is not a complete equation, that's a proportional relation. There are two constants are required, k and b are two constant presents, and they form the total formula is root nu, it's not v, it's actually nu, equals to k into z minus v, but these two are constants. And that gives us the basic concepts of Moseley's law. If any kind of numerical is given, then you have to use the total formula, then the value of k and b will be provided in the question. And we can calculate from there the atomic number or the frequency of the characteristic spectrum. So you can see there is a much greater detail we can understand about the characteristic spectrum, and they can be very much helpful in even knowing the value of the Z, and this also helps to verify the periodic table in the future. Thank you. In the next class, we will learn how to solve numericals.